Okay. Welcome to the next, latest, and greatest webinar on CIS-210 here at Georgia Military College. I am Professor Lusby, and yeah, I wanted to create a week two webinar recording here that really goes over what it is that you need to do for week two. Very similar format to what I did last week. A lot of you are finding it very useful and providing me feedback, and I really appreciate that. Okay. But with that said, if you did miss week one, if you did miss the introduction video, those are posted here at the top of the classroom. Please watch them. They have a lot of good information. And in the introduction video, I explain or go into a little bit of detail as to what's contained in all these links at the top. I'm going to assume everyone is familiar with all of that by now. The most important link being this glorious virtual desktop that GMC has set up for us that has everything installed that we need in order to create a Java or JavaFX application. And again, I'm going to be demonstrating how to use this virtual desktop for your week two assessments. All right, but let's just dive right in here. Let's go down here to week two, which is where we are. And we'll see that this first link, right, we have overview and objectives for each week. Uh, Here gives us a high level view as to what we're doing, right? We're really going to be looking at data types this week. So last week we learned how to output data to the screen or the console, and that's definitely step one, right? Being able to show the user um, some output. But now we're going to get into, well, how can we store values inside the computer? And that is using these different data types, these different variables, some mathematical expressions, right? Because that's typically why we write a computer program, is so that it does the math for us. We'll talk about uh, some of that. All right. Yeah, and manipulation, storage and manipulation of multiple data elements, right? We can create programs with multiple variables, not just one, which is why they are so powerful. These are our objectives, and we'll talk more about this as we go on. All right. So that is our overview and objectives. For this week, your reading material is Chapter 2 in the Java Illuminated 5th edition, which is this chapter right here. We're getting into some Java basics. Java basics meaning, yeah, again, data types and variables, right? Super important. Uh, we need to be comfortable and familiar with how to declare a variable using a proper data type. And you're going to see that every programming language has about a handful of primitive data types. Um, and they're basically same across the board, right? Every programming language has an integer, a floating point, data type, uh, character, string, Boolean. And again, we'll get more into detail in a second about this, but for sure, you want to read over chapter two and be comfortable with all of this material, definitely before the quiz, right? Because the quiz does cover chapter two of your textbook. All right. And then it gets a little bit into the arithmetic operators, right, and some expressions. We'll go over what that means here in a second, but yeah, we need to get good at putting math formulas into these programs so that they can do a lot of the work for us, and that's what that's about. And then there's a couple of programming activities. Almost all these chapters have a couple of really good programming activities that see if we can apply the knowledge that's being presented. And again, I'll go over at least the discussion one with you for sure, and we'll talk about that here in a second. All right. So for sure, read chapter two, be comfortable with chapter two. And then, of course, every week has some supplemental resources, meaning these are optional resources. Again, some students find these useful, some students find these confusing. But at the end of the day, feel free to take a look at these. And there's way more than just this, right? The internet is full of really good resources, but there's also full of some misleading and strange resources. At the end of the day, if and these are good resources, that's why they're listed in the classroom. If you're confused with any of the supplemental material, always come back to the textbook. That is uh, the material we need to learn for this week. And if you have trouble understanding that material in the textbook, that's why we're here. Definitely email me. Let me know how we can help. All right. All right. So enough about that. Let's talk about the nitty gritty. What is it specifically that we need to do for this week? What is it we are being graded on? And the first thing is this week two discussion. All right. And the week two discussion basically wants you to complete, excuse me, this programming activity two, the temperature conversion programming activity. Um, and it says once you've completed it, this is a little misleading, at least for me. I want you to take a good stab at it, right? And I want you to spend some time with it trying to complete it on your own for sure. But at the end of the day, this first post is due by Wednesday. If you're having some difficulty completing it, that's okay, right? This is a brand new programming language to you. Maybe that's what you talk about here, right, in your discussion. Were you able to get the application successfully to run? And if the answer is no, say that. Say no, and call out some of the errors that you're seeing. Call out some of that difficulty. Um, that is that is what this discussion uh, is for. And then maybe you could even read over, or you should be reading over your other posts from other students in the class, and maybe they can help guide you towards getting that to work. So you're graded on a good discussion post that has, good observations. You're not graded here in the discussion as to if you can find the solution, right? Because I mean, there's even some other questions here, right? What makes a Java program well structured? This is also an excellent question to talk about. So for sure, make an attempt at this, a good attempt. Programming takes time. That does not mean we'll try it for 5 minutes and give up. I would say at least for a good day, um, and at least a few hours even. Uh, and some bugs can take days to figure out. So I guess that's why I'm saying if you hit a brick wall and you've tried basically everything uh, as long as you're not, you're taking longer than 5 or 10 minutes, then post about that and post what it is that you're running into, as well as these other questions. All right, enough about that. Everyone should know by this point, right? Minimum post is 150 words. For the initial post, that's due on Wednesday by midnight, and then you want to respond to two of your peers or my posts over two more days. All right, but let's talk about this programming activity two. I just wanted to clear that up because I'm getting some questions about that. I can't find a solution by Wednesday. What do I do? And that's why I wanted to be clear, at least for me. Just post your observations and your experience when you were trying to create this solution. But what I want to show you now is, well, let's talk about this programming activity two. Let's talk about how to get to the solution, because that is definitely important as well. So we're going to bring up programming activity two here in the textbook, and you'll find that here. All right. And let's just kind of look over what it is that they're wanting us to do. Basically create a program that converts the temperature from Fahrenheit to Celsius. And they give us this formula here. The temperature in Celsius is equal to 5/9 times, okay? And this is kind of algebraic form. If you try to type this in directly into your program, the compiler, the Java compiler is going to have no idea what this is. So that's the other thing we need to learn how to do when we're talking about these expressions uh, in any programming language. In algebra, if a number is next to a parentheses, we say that means multiplication, all right? But to a computer, you have to call out this multiplication here explicitly, all right? And I'll show you what that means in a second. Some students have trouble uh, reading this formula or getting this formula to work in the code. And yeah, I'll show you in detail what I mean about that here in a second. All right. So we're supposed to convert Fahrenheit to Celsius. That's what this TCTF is. And they do give us a good template to start with, and I'll show you where to find that here in a second. And they do give us some good pseudocode, right? Each one of these lines here should be translated to at least 1 or 2 lines of code. And if we do so properly, we should find the solution. And yeah, it tells us to open this temperature conversion.java file. All right, how the heck do we do this? All right, go ahead and log into, right, the remote desktop. And I showed you where that link was earlier, right, kind of towards the top. There's a click here to access the virtual desktop. And once you do that and you log in with your credentials, you should see a screen, right, that looks like this. And again, this has everything installed and configured. You can hit the ground running here. All right, so the first thing we need to do is let's go ahead and launch NetBeans. All right, and you should see, well, let me close all this stuff here. You should see something that looks like this. Your project window in the left-hand side might look a little bit different, right? You might have some other projects listed, and that's okay. All right, but anytime we start a new project, we're going to come up here and we're going to say File, New Project. All right, Java application. All right, using NetBeans 8. Click on Next. And again, if I'm going too fast, hit the pause button. Right, hit the pause button and try to sync yourself up, and then hit play once you think you're at that good spot. That's why I record these. All right, let's give this a new good descriptive. Project name 22, well, at least for this term, but if you're watching this later on, I don't know, whatever, as long as it's descriptive. At the end of the day, trust me, you want it to be descriptive to find it later. CIS-210 week 2, what are we doing? The discussion. All right, so let's do the discussion. Create main class. Yeah, we do. I mean, you don't have to do this. You can create the file on your own and in the project, but this is going to do a lot of the work for you. So I say, you know what, just go ahead and have it create the main class. Get rid of, if you got a bunch of package names in the front with dot, just keep the last name at the very end there. All right, we're not, CIS-210, don't worry about packages. All right, make sure this is checked. Make sure this is unchecked. Make sure you do not change this path. A couple of you have already, and please, you're in a virtual environment. This default path, you have read and write privileges. All right, so do not change that path, and then a nice descriptive name. Go ahead and click on Finish. All right, so here we are. Here is our nice, wonderful file. Some of you are leaving these default comments, and I guess that's okay. I don't know. I really don't like the default comments. And when we get to the programming assignment, I'll show you what I'm looking for concerning comments here in a second. But concerning the discussion, I guess, you know what, let's just leave the comments. All right, but just know that anything in gray is, the computer is completely ignoring all this stuff in gray. This is just for the humans. All right, so if this stuff distracts you, I guess that's why I do this. When you're new to programming, you really want to get it down to, hey, this is the basics. All right, so I'm going to go ahead and delete that again. And every program starts with main, right? So that's why we have a main, and we're going to add our code, right, inside of main. But something just occurred to me. The instructions tell us that they already created a temperature conversion file for us. Dun, dun, dun. So here's what we're going to do a little bit differently. We're going to get rid of this file that we just created. All right. We still have our project, and that's important. And I'm going to show you why in a second. For these programming activities that already have a file created for us, here's what you're going to do. You're going to go into the GMC classroom inside of the virtual desktop. All right, log into the GMC classroom inside of the virtual desktop. You may have to type this in directly into the browser in the virtual desktop in order to get there. but for sure, if you type this in directly, you can get there. And you got to log in and all that stuff. Inside of the classroom, inside of the virtual desktop, down here, where is it? Here. CIS-210 Programming Assignment Frameworks. Go ahead and click on this. This will download a file. Go ahead and click on that file. Once it's downloaded, you're going to see the contents of that file. What we want is source code, chapter 2, and look, all the source code to all the examples as well that are in the textbook are here. But what we're interested in is programming activity 2. All right, here's the Java file that it's talking about. All right, how do we get this into NetBeans? Because a lot of you are just double clicking on it or opening it directly and starting to modify it and expecting it to run. No. Okay, so here's the Java file. We're going to minimize this. We're going to minimize this. We're going to go back to where NetBeans is the main application. All right, go ahead and bring up File Explorer in front of NetBeans so that you can see that Java file. All right, and you're going to hold the left mouse button down, drag it over here to the default package, and you're going to release that left mouse button. All right, and that will put it here inside of default package. All right, notice that you have to create a project in NetBeans, and you have to add the file to the project in NetBeans in order to get it to compile and run. You can't just open those Java files directly and run them. All right, there are some older primitive languages where that is possible. The newer languages, Java, C++, it is not. You always have to create a new project and tell that project what the files are that you are adding, that you're importing. All right, so here is the template for the discussion, and it wants you to fill in these lines of code here. But I don't want to bore you just typing in the solution here. So what I did was, right before this meeting, I went ahead and did exactly what I just showed you, imported this temperature conversion.java file into a new project. All right, and here is the solution. And my eye is twitching a little bit here. All right, the reason being that for full credit on your assignments, you are expected to have the code indented properly. And I'm getting this question a lot. What does that mean? Code indented properly. This code definitely is not indented properly, and that is why my eye is twitching. Indented properly means that after, remember the last class, we talked about Java code, right? We declare a public class, we give it a name, and we use these curly brackets, right? And it shows us the close one. These curly brackets to denote scope. And what scope means is, well, everything in between these curly brackets is part of this class. Even these curly brackets here, everything in between these curly brackets is part of this function called main. So these curly brackets denote scope. Everything inside of the curly brackets that is of the same scope should be indented the same. And that's not what I'm seeing here. I'm seeing a comment that's here. I'm seeing a line of code that's here that's indented differently. This one's here. This one's here. Even down, where is it? Down here. Look at this. We got comment here and code way over here. So this is not indented properly. So how do we indent properly? Well, we could do a couple of things. We can manually indent everything. So, and indentation is usually 3 or 4 spaces. So I'm going to go with 3 spaces. All right, 1, 2, 3. And you could literally, that's why they use tabs and not spaces. You could literally come in here on every line of code and manually do this. All right. In order to properly indent it. But let me show you an easier way. If you highlight everything hit Control A, come up here, say Edit, Cut, Edit, Paste Formatted. Oh, so much better. Okay, everything is nice and indented properly, and my eyes stop twitching. All right, in industry, they do expect that you know what indentation is and how to properly indent. Okay, it'll still run even if it's indented all over the place. You'll still get the correct behavior, but if you have a code review, people are going to laugh. All right, and I don't want people laughing. All right, so just make sure that if the indentation looks wonky, just do what I just did. Hit Control A, come up here to Edit, say Cut, then say Edit, say Paste Formatted, and that will format the code correctly. And when you get to more complex programs, right, that have hundreds or thousands of lines of code with a bunch of if statements and a bunch of nested loops, indentation is going to become super important to read that code. So that's why I'm harping on indentation now. And in fact, some languages, like Python, if you don't indent the code properly, it doesn't compile, right? The indentation determines the scope. So I'm trying to get you all into good habits here with your indentation, because for some languages, literally, it won't compile or work if you indent it wrong. All right, so just keep that in mind. For full credit, you do need proper indentation. Now, let's see if we can read each one of these pseudo comments here and figure out why these are good lines of code that do that. All right, number one, declare any constants here. Well, for sure, in this formula, and what does constant mean? Constant means, do you have any variables or values? Do you have any variables or values that don't change? All right, and do they tell us that 32 is a constant? They do not. That's a big assumption, and I guess if you didn't know 32 degrees is the freezing temperature of water, well, it's still a constant. Literally, this value here is not going to change. So because it's a constant, and this is mentioned in chapter 2, you put the keyword final in front of it. And in fact, I think I even talked about that a little bit in the previous weekly webinar. All right, so that's what this final guy is. It's basically saying, hey, this variable here cannot change because the freezing point of water will never change. Depends on how much pressure, but that's beside the point. All right, so freezing point, int. What is this int? This means it is an integer or a whole value. All right, that's one of those data types, right? Back here in 2.2, you learn about the int or the integer data type, and it is a whole number. All right, so that's why we use int. Freezing point, notice how it's in all caps. The reason why we do all caps is because it is a constant that will not change. It is good programming practice. Anytime you have a variable that cannot change because it's a final or a const, you put it in all caps so that when other programmers see this variable, they're not going to try to change it. They know that this can't change. All right. And finally, we use the assignment operator or equals, and we give it a particular value, in this case, 32. So declare any constants. It's expected that you could look at that problem and figure out, well, freezing point is a constant, and we should. And do we have to call it freezing point? No, you could, I don't know, freezing point of water. I guess we could give it, right? Oops, please hold. We could give it a better name if we wanted to be really descriptive. Right? Now, if we do that, we got to change it wherever we use it in code. All right. So as long as it's a nice descriptive name, everybody's happy. All right. Number 2, declare temperature in Fahrenheit as an int. All right. Well, it kind of gives Fahrenheit as an int. So for sure, it's an int data type or an integer. For sure, it's a whole number. And declare temperature in Fahrenheit. They're not really telling us the name, but Fahrenheit is probably a pretty darn good name. But maybe we want to be a little more descriptive, and maybe we want to call it Fahrenheit temp, just in case. Maybe there's some people out there that have never heard of Fahrenheit, and maybe we want to really be descriptive and say Fahrenheit temperature, and then everywhere we use it, Control C, Control V. There is another way to do this, but I'm going to talk about that in future webinars. It's called refactoring and letting NetBeans refactor for you. All right, so Fahrenheit temperature, right? We declared a variable called Fahrenheit temperature. That's an int that is, and notice the 68 is kind of coming out of nowhere. They don't really tell us what temperatures we need to test. I don't think, do they? No. So it's, oh, they do tell us 32 is freezing point of water. So it's completely up to you, really, what you wanna set this to. All right. So pick any value there, and this is our input data. All right. In fact, yeah, I'm going to start to harp on this early. Every program has an IPO paradigm. There's input, there is process, and there is output. Input, process, output. That is what every program on the face of this planet does, and every electronic device, and every computer. It's the whole reason they exist. IPO paradigm. All right, so here's the input, here's the process, right? Okay, what does the process do it? All right, calculate an equivalent Celsius temperature. So for sure we need to declare a variable that we can store this temperature in. In this case, we pick Celsius, but we could pick a different name. As long as it's a legitimate name, we're fine. Here it is a double data type, and in chapter 2, you'll learn that a double is a fractional value that can contain a decimal point in it. So it's kind of weird why they force us to use an int here, but I think I know why. All right, because in theory, in industry, I would make this a double as well. But here they force us that Fahrenheit needs to be an int. And then here, remember that formula, right? 5/9. The multiplication is implied here, right? You have to know that from algebra. 5/9 times the Fahrenheit temperature minus 32. Well, that's what's here. 5/9 times Fahrenheit temperature minus 32. And look, freezing point of water 32. So that is the same formula that the book uses. This is the multiplication sign for programming languages. It is not this. All right, a lot of students who are new to programming try to use this X as the multiplication sign. It is what's called the asterisk. If you hold down the shift key and push the number 8, this is how you multiply in the land of programming. All right. The other important thing to note here is that notice here they're using two whole numbers, 5 divided by 9. If you do that, well, let's run an experiment, and I'll show you in a second why this 0.0 is so important. It seems kind of overkill, seems kind of ridiculous. Well, it's the value 9. Why do you throw 0.0 in there? And I'll show you. I'll show you here in just a second. All right. But high level, this is definitely the formula that was called out in the book. All right. The fourth step here, output the temperature in Celsius. All right. So we learned in week 1 we can use the system out print line guy, right, to output some data. So that's why we're using this. And we can concatenate a bunch of data together, right, using this plus operator. So it's going to print out this string, and then it's going to print out whatever the value that is inside of Fahrenheit temperature is. Then it's going to print out this string, and it's going to print out whatever the value inside of Celsius is, and it's going to print out this string. All right. And then on, give me just a sec. All right. Then here on line 5, it says, well, they want us to convert it back, assuming that maybe we just have this Celsius temperature and we have no idea what the Fahrenheit temperature is. Just kind of a weird thing to do because we said it was 68 already, but just to kind of do a gut check and make sure that we can convert it not only the one way, right, from Fahrenheit to Celsius, but let's also see if we can convert it back the other way from Celsius back to Fahrenheit. And in order to do that, did they call that out? Let's see here. Yes, they do say, well, hey, if you want to go the reverse, go away. I hate it. All right. This is the formula in reverse. So notice this is 5/9, TF minus 32. If we're going the other way from Celsius to Fahrenheit, we want to use 9/5 times TC plus 32. All right, so that's where they're getting this formula here. And it is a little bit different than this formula here. All right, but again, it's the same formula, and instead of using parentheses, they do actually use the asterisks here in order to represent multiplication. All right, so that's where, and apparently we're going to reuse that same Fahrenheit temperature variable. That's going to overwrite whatever that 68 guy was that was in here. We're going to overwrite it with whatever this is equal to. All right, and in line 6, again, we're doing another output. So really, we're doing two processes and two outputs here. And sometimes you'll see this in the real world. But usually one function, like that's main is a function, does one process and one output. Well, main's an exception, but most other functions all just do one input, one process, and one output. All right, so that's why this solution is what it is. Let's see it actually work in action. So here's what I'm going to do. I'm going to put a breakpoint here on line 9. You see how I did that? You actually click on the number 9 itself, and you'll see a little red dot, and you'll see a red line here. Once you add this breakpoint, we're going to be able to step through this code and watch and see the computer run it. All right. So number 1 is I'm going to add this breakpoint, and this is going to come in handy later on when you have complex applications. You're going to want to step through the code. It's not going to be easy just to eyeball it and see what's going on. All right. So I'm going to set this breakpoint. I'm going to right click here and say debug file. All right. And it should launch the debugger. And yeah, you see this green guy? This is the program counter. And I think we did a little demo of this last week. What that means is, yeah, the computer stopped here on this line of code. It's showing us the variables window down below. So it's showing us what's in memory for this program. Right now, there's not a whole lot going on, right? And so when I step over line 9 here, I would expect to see this variable, this integer variable, appear down here in memory. So I'm going to hit step over here. And we do. Here's freezing point of water. It is an integer, and the value is 32. So that looks good. This line is behaving and doing what I expect. Line 13, notice it jumped to line 13 because this is the next line of code. All these comments are completely ignored, right? So it jumps down here to line 13, and I would expect line 13 to declare a variable called Fahrenheit temperature down here and set it to 68 as an integer. Fahrenheit temperature is an integer. Here's the value 68. Great. Then it goes to the next line of code, which is line 17. Aha. And okay, we got a lot going on here. What in the heck do I expect to see? Well, first of all, we have an assignment operator here. And the way the assignment operator works is it has to do everything on the right-hand side first, and then it'll take that value and put it inside of this variable on the left-hand side. So the question is, well, what in the heck should be on the right-hand side here? Well, if we hover over Fahrenheit temperature, we'll see that as 68. We hover over freezing point of water, we'll see that's 32. So whatever 68 minus 32 is, I'd have to do the math on a calculator. And then multiply that, right? We have to do that first because there's parentheses here, PEMDAS, right? The computer follows PEMDAS. Parentheses, exponent, multiply, divide, add, subtract. So it's going to do this value first, 68 minus 32, and then it's going to multiply that, right, times whatever 5 divided by 9 is. And I guess we could Google what is 68 degrees to Celsius. But it looks like if we hit step over here, I would expect to see a variable called Celsius down here with a valid value. All right, and I can't really do the math in my head, so I can't really tell you what it should be here. But yeah, here's Celsius, here's a double, and it is a 20.0. It does include a decimal point. That sounds reasonable to me. Yeah, 68 degrees is somewhere around 20 degrees centigrade, centigrade, um, or Celsius, 20 degrees Celsius. Um, okay, so that looks good. Now, line 21, well, how do I verify this line? Well, I should see this string with Fahrenheit temperature. Well, Fahrenheit temperature is 68. I should see this string plus Celsius. Well, Celsius is 20.0, and then I should see this string. So when I click on step over here on line 21, in the output window, I would expect to see all this information on one line. Let's see if that happens. We do. A temperature of 68 Fahrenheit, right? Temperature of 68 Fahrenheit is equivalent to 20 degrees Celsius, 20 degrees Celsius. So that looks good to me. So line 21 did what I expect. And then now line 27, all right. So we do have an existing variable called Fahrenheit temperature. It's currently equal to 68. It's going to do the math here on the right-hand side first, right? We have an assignment operator. It's going to do this math first, and it's going to take the result and store it here inside of Fahrenheit temperature. The problem is right now, Fahrenheit temperature is 68. In theory, this formula is also going to give us 68. So we're not really going to see anything happen. At least I don't think so. So let's hit step over here, and in theory, this should remain the same value if this formula is correct. Yeah, and it does. So I don't know. A better way maybe would be to declare two Fahrenheit variables, one called Fahrenheit temperature 1 and one called Fahrenheit temperature 2. And in theory, use Fahrenheit temperature 2 here and just verify, well, does Fahrenheit temperature 1 equal Fahrenheit temperature 2? But that's not what they did here. All right. So this formula looks good, and it did what I expect. It put the same value back into Fahrenheit temperature. And then we get to line 31. All right, well, this is going to output to the screen this string plus whatever Fahrenheit temperature is, which is 68. So we should see this string in the output window and then 68. So when I click on step over here on 31, I'd expect to see that in the output here. Converting Celsius back to Fahrenheit, we get 68, and it does. All right. Now we've hit the end of the program. So this is the close curly bracket to main. How do we know that? Because of indentation. If we follow this closed curly bracket up to the top, we'll see it lines up with main. And even some programmers go so far as to push this open curly bracket down to the next line so that you can really see that they line up. But anyways, we're at the end of the program. I think, yeah. If I click step over here, we should see it exit, and it does. All right. So this is the solution to the discussion. Did you have to do all that before you could post? No, but if you can do all that before you post, well, you're in a really, really good position because this helps prepare you for the programming assignment this week. Aha! Let's talk about that. Let's talk about the programming assignment. Let me clear this breakpoint here. And let's just go ahead and close this. All right, so that was for the discussion. I just walked you through how to complete the programming activity for the discussion. What about for this week 2 programming assignment? Here is the week 2 programming assignment. Notice that we are supposed to write a program, right, that holds the number of teaspoons in a tablespoon. All right, so if you're a chef, maybe this application would come in really handy. I don't know, because you're tired of using teaspoons. All right, so declare a variable to represent the number of teaspoons needed for the recipe, compute the number of tablespoons and remaining teaspoons, and then basically show it to the user. So for instance, if we did put in 16 teaspoons as our input, well then the output should be 5 tablespoons and 1 teaspoon, and the output should look something like this. But in order to really test our program, normally you don't want to just do one test. You want to do several tests. And that's what this table is showing us here. We'll test out 16, make sure you get the proper output. Test out 8, make sure you get the proper output. Test out 24, make sure you get the proper output. All right. So at a high level, this is what we're supposed to do. All right. How do we go about doing that? Well, let's go back to our handy dandy virtual desktop. Let's go back to NetBeans. NetBeans 8. Go ahead and double click on NetBeans. Bring that up. We're going to create a new project, right? For each one of these, we're creating new projects. Java application. Give it a nice descriptive name. WNCMP. What is this? Week 2. And I'm going to call it week 2 assignment, I guess. Why not? Don't change this. Leave that as is, the default folder. Don't check this. Here, yeah, let's go ahead and create a main class. The only time we don't create a main class is for the discussion, because we can import the file, right? I showed you how to import the file from the classroom. But for all the programming assignments, it's assuming you're writing it from scratch. So yeah, fine. Let's create a main class here. All right. Here's our main class. As always, nice name. And I'm going to get rid of these. All right. And this is how we're going to start for the week 2 assignment. We created the project. We created the class. Now, real quick though, I believe the requirements say, did they give us a name for the Java file? They do not. So you can name that Java file anything that you want, because it says correct file name that matches the class name, but they don't really tell. Oh, here it is, tablespoon converter. Say the program is tablespoon converter. All right, if you create a project and you give it the wrong name, and I've already gotten this question a couple times, let me show you an easy way to fix that. Go ahead and double click, no, here. Come over here in NetBeans, right click, say, what is it, refactor, and say rename. And so instead of CIS, we want to call this table, what was it, tablespoon converter, tablespoon converter. Okay, apply rename on comments, sure. We don't have any, but whatever. Let's click on refactor here. And what just happened was it renamed a class for us, but it also renamed the Java file. Remember that Java, right, the file name has to match the class name. So refactoring is probably the safest way to do this, especially if you have a bunch of other code files that use that old class name. Refactor will look for all those and replace all those with the new name. All right, so at least I wanted to demonstrate that real quick. In case you create your class with the wrong name, you can always refactor it and rename it. Please don't try to do that manually, because maybe this class name is used in a bunch of places that you don't know about. Okay, so this is how we start. Well, what in the heck do we need to do here? And instead of typing in this code and boring you, behind the scenes, before this meeting, I came up with this. All right, did exactly what I just showed you, created the new project, but I want to kind of show you what I'm looking for full credit, number one, and number two, I want to give you some guidance as to how we can go about completing this program, because you're new to programming, right? And for a lot of students who are new to programming, just coming up with the structure it is a little intimidating. So I at least want to come up with the structure, kind of help you out using some pseudocode here. But I do expect that you can translate the pseudocode into actual Java code. All right. But first things first, I'm getting a lot of question on what does it mean comments, right? For full credit, where is it? Here. Java code is properly indented. We talked about that. You know, indent code now. Code comments are present within each major section of code, and name and date and assignment information is at the top of your code file. These both are what they're referencing as comments, and that's why this is here. I would expect to see a header at the top, giving a nice description as to what this Java code file is, right? Obviously, you're going to change that to whoever you are, and obviously, you're going to change that to whatever the current day is. And major comments above each major section of code, well, that's comments like these, right? Kind of letting whoever's reading this code know at a high level what they're looking at. All right. Here, I intentionally get very granular with these comments. I would at least like to see a comment above the code in the input section, a comment above what process is going on, and a comment above the output. Do you need to comment every single line of code? If it helps you, yes. If it doesn't help you, no. But if it's a major section of code, please give at least a brief description as to what that major section of code is doing. All right, so back to how do we go about solving this tablespoon converter? That's why I put these comments in here. Typically, you do declare your variables or your constants at the top of, maybe I put the constants and variables at the top of the function. All right, so that's why I'm saying let's do that here. In particular, right, we're going to need a variable to store the number of tablespoons in a teaspoon. This does not change, it should be constant. Well, why does it say that? Well, because it tells us here, 1 tablespoon is equal to 3 teaspoons, right? So for sure, you want to declare a constant variable there that calls that out. 1 tablespoon is equal to 3 teaspoons. Then for the input, we're going to declare variables for all the input that we need to this particular program. In particular, yeah, we need a variable that stores the number of teaspoons, right? And I guess it's up to you what you want to name it, but I like to call out names here in pseudocode so that I can reference these same names in the pseudocode later on. All right, do you have to use this name? No, you could use another name if you like. But let me show you why I say that. Because, so here I'm saying, okay, there's a variable called teaspoons amount. Well, that's one piece of information we need. But we also need another variable that's going to store the number of tablespoons that are in this variable. And so maybe create another variable called tablespoons amount, right? So we got a teaspoons amount variable, we got a tablespoons amount variable. Notice I'm not specifying what the data type is for these guys because, well, I kind of need to know that you can use a good data type here. Which one is up to you, right? And chapter 2.2 calls out all these nice, wonderful data types like integer, float, boolean, character, string. There's only a handful. All right. So look into those to figure out what data types you need. Declare a variable called remaining teaspoons to store the remainder of the teaspoons, right? Because if we look here, I'm sorry. When our output needs to call out how many total tablespoons and how many remaining teaspoons. If it gives us a nice whole number, like for instance 24 teaspoons, well then fine. We just have 8 tablespoons and we don't have any remaining teaspoons, but that doesn't always happen, right? Like for 16 teaspoons, we do have some leftover teaspoons. So that's why I'm saying, well, you need a third variable to call out what those remaining amount is. All right, for the process, yeah, that's the whole point of this application. We want to calculate how many tablespoons are in teaspoons and then store it in this variable called tablespoons amount. And again, if you change these names up here, that's fine, but you're going to have to change whatever names you use down here in the process section as well. Well, once we have how many tablespoons are in the teaspoons, we also need to calculate the remaining teaspoons using teaspoons amount, tablespoons amount, and store that result in remaining teaspoons. All right, a lot of math going on here, and I'm going to help you out with this here in just a second. And then finally, output. Yeah, we want to print out to the screen or console whatever those values are, right? That we calculated up above, right? IPO paradigm: input, process, output. So at a high level, this is what I would expect to see um, for the code. Is this the only way to do it? No. There's 10 different ways to write the same program, sometimes even more, 100 different ways. And at the end of the day, as long as your output looks good with whatever input you provide it, well, then that is a valid solution. All right. So this is one possibility, but there are others. All right. So I'm sure this is usually where I get asked the most amount of questions. And so here's what I did, and I was like, well, how do I really explain this math part? And that's what drives me crazy. A lot of these textbooks on programming, they love to focus in on the math. And at the end of the day, yeah, if you're good at math, typically you pick up computer science or programming fairly quickly, but you don't have to be good at math to be good at computer science. I've known plenty of other programmers who were not mathematically inclined that did amazing with data-driven applications, okay? So don't get frustrated on this math part. Here's what I did there. Let me show you an example of an eggs converter. Very similar assignment, well, not assignment, very similar example where instead of tablespoons to teaspoons, or the reverse, teaspoons to tablespoons, we want to call out, well, how many cartons of eggs do we need? All right, and I hope you can see the similarity, right? Before we had this many teaspoons equals this many tablespoons and remaining teaspoons. Here I'm saying, well, we got a bunch of eggs. Well, how many cartons of eggs and how many leftover eggs do we have? And very similar flow here, right? Declare the constants. Well, if we're talking about eggs in a carton, well, that is a constant. There's only 12 eggs in a carton, so we can call that out as a final value. All right, so we declare a variable called final, int, which is an integer. Here's our eggs in carton, and we set it to 12. Well, for the input, yeah, we need to know the number of eggs. And right now, we're just hard coding this value into our program. Even here in your tablespoon converter, you're going to hard code this teaspoons amount. Eventually, in week 3, we're going to learn how to ask the user for input and allow the user to type in input at runtime. Right now, we don't know about that, so we're just hard coding whatever it is, the value that we want to use for our number of blah. All right. Next, we want to create a variable that's going to store, well, if we have this many eggs, how many cartons are required? And sometimes it's a good idea to just create the variable and initialize it to a good default value, usually 0. And then in the process section, you're actually going to put the real value in here. So that's kind of what I'm doing here is I'm creating a variable that eventually is going to store the total number of cartons, but right now just initializing it to 0. And in this case, I'm using an integer. Notice all of these are whole numbers, so that is why I'm using integer here, but that may or may not be the case here for your assignment. So maybe do some research into that. And then another variable, well, yeah, we need another variable to store the remainder of the eggs, right? So if we have 14 eggs, well, that should be 1 carton, but then there's 2 eggs left over. So we need another variable to store the remaining eggs that won't fit in the total carton. So I'm creating that here and assigning it just a good default value. Now here's the math part. Notice that in order to figure out the total number of cartons, and this is usually pretty easy for most students, you take the number of eggs divided by, well, how many eggs fit in a carton, right? So if there's 14, 14 divided by 12 is equal to 1 point something. But the key is the 1. For sure you need 1 carton of eggs. And the cool thing here is the way that I'd say almost all languages work is if you take an integer, which is number of eggs, integer, divided by another integer, which is this constant variable up here, right? It's an integer. It's going to automatically, integer divided by integer, it's going to give an integer result. So because 14 divided by 12 is 1 point something, that point whatever is just going to drop off. And what's going to end up happening is total cartons is going to be equal to 1. And I'm going to show you that here in a second. We're going to step through the code, and I'm going to show you why we don't need to worry about that point whatever, because we're doing integer on integer math, and it's going to automatically create an integer, and it's going to drop off that whatever that decimal is. And in this case, that's a good thing, because we can't have a 0.2 carton. Well, I guess you could. You could cut the carton a little bit. And anyways, we don't want a 0.2 carton. So as long as we're doing integer divided by integer math, it's automatically going to create an integer, and it's going to get rid of that decimal portion. But then the question is, well, how do we figure out how many eggs are remaining, right? If 12 of those eggs are going in the carton and we have 2 left over, how do we figure out that with math? And this is where what's called the modulo or the modulus operator comes in really, really handy. What this percent sign, we're used to this percent sign meaning however many percent out of 100 something is in the real world, right? We say 50%, well, that means 50 out of those 100 items is blah. Here in programming, in the programming world, just like X doesn't mean multiplication, percent doesn't really mean percent, even though we call it percent. This is what's called modulo. And what that does is it takes whatever is in this variable, let's say 14, it divides it by whatever in this variable, let's say 12, and instead of storing the value 1, modulo stores the remainder. Okay, so 14 divided by 12 is 1 remainder 2, correct? Right? 14 divided by 12 is 1 remainder 2. So what the value of this is going to be, because we're using modulo, is 2. This modulo operator returns the remainder, not the whole number. All right, returns the remainder, not the whole number. And that comes in handy for situations such as these, and why I wanted to bring this up and show this to you, because it involves using this modulo operator that tells you what the remainder is, and you kind of need that here, right? For calculating how many teaspoons are remaining. One way to do it is using this modulus operator. There are other ways. If you find another way, by all means, as long as you come up with the right result, and you come up with the right cartons, and you come up with the right eggs, or you come up with the right teaspoons and the right tablespoons, you found another valid solution. But that just highlights the importance of testing, right? That's why it's so important to test your algorithm to make sure you get the right output. And then finally, at the end, this line of code should print out string plus, should return our result here. So let's step through this, and let's make sure that we understand this code's behavior, and let's verify it, right? Because without stepping through it, without running it, we can't verify its output. So I'm going to go ahead and run, debug this. All right. And let's see here. So we're going to hit line 13, eggs and carton. When I step over line 13, I should see this down here in the variables window, and I should see it populate to 12, and it does. I just stepped over line 13, eggs and carton is an integer with the value 12. Perfect. That did what I expect. Line, let's see, what is this? 17. Number of eggs equals 14. When I step over line 17, I should see number of eggs down here, set to 14. I'm going to hit step over. Number of eggs, int 14. That's exactly what I would expect. So that's good. Line 20, total cartons equal to 0. I'm going to hit step over. Should see a new variable down here. Total cartons equal to 0. Perfect. Line 23, remaining eggs is equal to 0. Step over this. We see remaining eggs, integer equal to 0. So all this code so far looks good. All right, here, line 27. Take the number of eggs, 14, divided by 12. Well, that's 1 point something, right? 1 point something. And it should take that value and store it into total cartons. All right, so let's see if that happens. Yeah, here's total cartons. Look, the number 1, not 1 point something. And the reason is that integer divided by integer equals an integer. It got rid of whatever that decimal portion is. All right, so very important when you're creating these formulas that you look and see what the data types being used are, because if everything is an integer, you're going to lose precision. You're going to lose that decimal part of the answer. If you want precision, I'll show you how to do that here in a second. Remaining eggs, we're on line 29, equals number of eggs, 14, modulo 12. Well, 14 divided by 12 is 1, remainder 2. So that is what we should see here. 1, remainder 2. So we should see a 2. Remaining eggs should be set to a 2. All right, because the remainder is 2. I hit step over here. Remaining eggs is 2. So it did properly calculate and find there are 2 eggs left over, and we stored it in this remaining eggs variable. And then finally, line 33 is, all right, well, let's print this out to the screen. This string plus number of eggs, which is 14. This string plus total cartons, which is 1. This string plus remaining eggs, which is 2. And then the word eggs. So when I click on step over here in the output window, notice how when you're running the debugger, you do sometimes need to switch between these tabs here. All right, so in the output window, I should see that a chef that needs 14 eggs needs 1 carton and 2 eggs. All right, and then step over, that should be the end of the program. It should exit, and it does. All right, so that looks good. And we could always, at this point, now that we've stepped through the code, just run it. I don't know, put in a random value. Let's say 18 eggs. Let's just run it instead of debugging it. Does that look good? Ooh. What? Chef that needs 14 eggs. Hang on, please hold. Looks like it is not saving my changes. Let me do a run, clean and build. All right, now let's try to run this again here. Oh, I changed this. Oh, whoops. All right, so even I make mistakes. Look, number of eggs is here. This is a constant value that doesn't change, but what did I do? I changed it. Eggs in a carton will always be 12. And this is the problem. Without asking the user for the number of eggs, we're going to come in here and we're going to accidentally change one of the wrong values. This is why in week 3, we're going to learn how to get the user to input some values at runtime, okay? All right, let's try this again. Number of eggs is 18. Eggs in a carton is still 12. Let's run it. All right, a chef that needs 18 eggs needs 1 carton and 6 eggs. All right. So, and back to the precision thing, doesn't, well, fine. Let me show you what I mean. As long as one of these is a float or a double, and as long as the result is also the same data type or double, then, oh my God, and it forces this to be. Right, so if we do that, if we really want that precision, if we really want that data type to be a double, we got to change all 3 of these to a double. And the thing is, the output's going to look weird if we do that, right? Because if I run it now, A chef that needs 18.0 eggs needs 1.5 cartons and 6 eggs. Well, that doesn't, I guess you could cut a carton in half, but if you can cut a carton in half, well, we don't have 6 eggs left over. So in this particular case, it doesn't make sense uh, to use a double. Um, we should leave it as an int. But notice how changing the data type changed the result completely. All right, so picking the proper data type is definitely, step one when we're learning how to program. We want to pick the proper data types. All right. Whew. Well, I went over a little bit long, but I really, when you're new to programming, I really wanted to get down into the weeds here and explain and give you a good example, right? This is definitely high level what you need to do to complete your week 2 programming assignment. And this is a similar example. And as long as you can look at this and look at this and come up with the solution and get this to run, and let's say you test it with, what is it? These, where did it go? Test it with 16 teaspoons, 8 teaspoons, 24 teaspoons. And I would say this, when you test each one of these using your program, I need the output. I need you to screen capture each different run. And I need to see this is, right? This is the output. This is the output. This is the output. At least 3 different screen captures here, not one, in order to fully meet the requirements, in order to get full credit, because down here, right, in the results document, screenshot a program running showing proper output for all test conditions. For all test conditions. All right. So for sure, make sure once you come up with what you believe is a good solution here, that you are testing it with these 3 sets of values and you're taking screenshots of the output for 3 different runs using these 3 input values, and you should be able to verify these correct output values. All right. Whew. What else? Is that it? I think that's pretty much it, other than the week 2 quiz, but very similar to last week. What is it? 10 questions, 3 open response. You have 25 minutes, 1 attempt. So for sure, make sure that you are comfortable with chapter 2 before taking this, and it's due Sunday by midnight. All right. I hope everyone is still finding these webinars useful. Definitely keep the feedback coming. Either like the video, comment on the video, whatever. Send me an email. That's what keeps me going, and I really appreciate it. All right. So have a great week 2, and definitely reach out via email if you need anything at all.